Hello guys, good evening everyone. Is everything clear? Video, audio, is everything clear? Shall we move on? Yes, myself, Krishna Prakash. Students love to call me KP sir. Good evening, Shadan. We'll move on now. Small announcement before starting the session. The regular advertisements, small announcement. You know it very well. From December 8th onwards, I'm going to start new batch of GATE ESE AAA. In this, what I am starting is open channel flow. Full length course of open channel flow, 45 hours I am going to teach open channel flow, only open channel flow. Okay. So if you or your friends or juniors, anyone want to take plus subscription, ask them to use the code KP Civil. Okay, don't forget about the code. And a new policy in Unacademy. Good evening, Banu. Good evening, Manoj. Good evening, Harish Verma. Srikandan, hello. Good evening. The new policy in Unacademy. If you are going to download Unacademy app first time, you or your friends, or you are going to watch any free class, it will ask regarding code. The code for your free class. What is your code? The code for your free class is KP Civil. Don't forget about it. If you want to start your free courses in Unacademy. Good evening, Sumit. Good evening, Ramakrishna. Your code for free classes in Unacademy is KP Civil. Don't forget about it. And Unacademy will provide so many unlimited test series for you. Online test series for each and every exam in India. So recently it is launching UPPSC AE 2020 Revise India test series. All India mock test is going to start on 6th December. UPPSC AE All India mock test is going to start on 6th December. So you write it, you understand the depth of the questions, you enjoy the test. So coming to our course, we are going to start from December 1st. We have started from December 1st. Crash course on environmental engineering, exactly needed for GATE. Not more than, not less than, exactly needed for GATE. Ramakrishna Super 30 test. Yes, Harish, it is helpful for TSPSC also. Because whatever the name we are putting, the name AEE standard is same. Na? Any state government AEE standard is the same. So that will be helpful for TSPSC also, Harish. That is helpful for TSPSC also, no problem. The names state to state we divide. But subject, content and quality of questions, model of questions is same. No change. And regarding Super 30 Ramakrishna, I think you have my number. I will send the link. Super 30, every week I am conducting free online test series in all the subjects. 30 questions week per week, one subject. We have started with environmental. Now we are going ahead with strength of materials. Today at 5:30, 30 questions of GATE standard, very tough questions. 1.5 hour exam, every Thursday it is conducting. So you send a link, message to me, I will send the link how to write the exam, I will send the link. Okay, Ramakrishna? Coming for today's session, we are going to discuss about quality of water. I told you, I promised my students, especially those who are requesting for free classes, I promised students to take environmental engineering, each and every topic in the form of full crash course, fast and furious mode. All concepts covered in 7 to 10 hours. Numericals will be completed in 20 hours. Means we are focusing more on numericals. Good evening, Karthikeya. Yes, this class 100% it will carry short notes. It will give you short notes for AEE, Harish Verma. It will give short notes for your AEE. Very much useful for you. Quality of water. Quality of water. So what quality of water you are going to study here? The objective of water supply project is to provide potable water as per IS 10,500 water quality standards. Hello, Srikandan. Yes, potable water is the ultimate target of water supply project. Every day we are receiving water through our municipal tap or corporation tap. In your house you are collecting water through municipal tap, corporation tap. So what quality water they are providing? They are providing potable water quality, which is according to IS 10,500 water quality standards. And this quality of water based on properties, based on parameters, it has been differentiated into physical quality standards, chemical quality standards, biological quality standards. The quality of water has been differentiated into physical quality standards, chemical quality standards, biological quality standards. It was very difficult for me to precise quality of water. You understand, you know it. Around 20 to 25 hours we are talking about quality of water only in full length course. Most of you experienced it. Now that 20 to 25 hours sessions, we are making precise in the form of 1 hour theory. 1 hour theory. So this modification of physical quality, chemical quality, biological quality. Why all these modifications? All these biological, physical, chemical quality because of impurities in water. And these impurities we are writing 3 types. Suspended impurities. The impurities we are writing suspended impurities. These are the particles of diameter. 10 power minus 1 to 10 power minus 3 mm diameter. 10 power minus 1 to 10 power 3 minus 3 mm diameter. Which include, we know it, which include sand, silt, clay particles. Sand, silt and clay particle. Colloidal impurities. The colloidal impurities are from 10 power minus 4 to 10 power minus 6 mm diameter. 10 power minus 4 to 10 power minus 6 mm colloidal particle. Fine discrete suspended solids. Only for this point I am writing this, because this is important previous question, especially GATE and AEE. This is important for GATE and AEE. Fine discrete suspended particles in water. Fine discrete suspended solids in water. SS means suspended solids. Those are called colloidal impurity. Dissolved. So all dissolved impurities are chemicals. All dissolved impurities are chemical impurities. whose diameter is 10 power minus 7 to 10 power minus 9 mm. Whatever the effect you are talking, it may be color, odor, turbidity, it may be hardness, pH, alkalinity, it may be MPN. Finally, all these are caused by three basic models of impurity. The three basic models we have written: suspended, colloidal and dissolved impurity. These are responsible for physical changes, chemical changes and biological changes in water. The modification, physical modification, biological modification, chemical quality modification, all are because of three type of impurity: suspended impurity, colloidal impurity, dissolved impurity. Clear? Completed writing. We'll move on. We'll go ahead now. Physical quality analysis. Physical quality analysis. The first type out of the three, physical, chemical and biological. Out of the three, first type we are talking physical quality analysis. We'll consider here temperature of water, desirable, best quality we can say 4 to 10 degrees Celsius, best quality we can say desirable, best quality 4 to 10 degrees Celsius, 4 to 10 degrees Celsius. Okay, adjustable or permissible, we call it as acceptable, adjustable or permissible 10 to 15 degrees Celsius. Then rejectable, we'll consider reject the water as sewage. Clay called as charged particle. Here the classification is based on the size. Ramakrishna. The classification suspended, colloidal, dissolved, what we have given, that classification is especially based on the size. Not about other properties, not based on other properties. Only based on the size we have given classification. Rejectable. Good evening, Ayush. Rejectable greater than or equal to 20 degrees Celsius. Greater than or equal to 20 degrees Celsius. For the same temperature, here itself I am giving information regarding sewage. Temperature between 20 to 30 degrees Celsius. Temperature between 20 to 30 degrees Celsius, it is called fresh sewage. Fresh sewage. More than temperature greater than 30 degrees Celsius, it is septic sewage. So in physical quality, we are discussing more regarding the limits only. We are discussing regarding more about limits, because these are the theoretical questions you experience in GATE and EAEE. Desirable, permissible, rejectable limits, sewage limits we have to clearly understand, because these are going to come in your exam. Okay? Yes, fresh sewage, septic sewage. Clear? We'll move on now. We'll go ahead now. Next point, next parameter. Completed writing, everyone? Next one, we are going ahead about color. Color. Always we need colorless. Always we need colorless water. Always we need colorless water. Color of water caused by. Color of water caused by iron, manganese, algae and fungi. Color of water caused by iron, manganese, algae and fungi. Very good, Banu Prakash. It is measured using color of water measured by tintometer instrument, Burgess scale. Tintometer instrument, Burgess scale, which is also called as, tell me, which is also called as platinum cobalt scale. Platinum cobalt scale. Very good Sai Tejasvi, very good Manos. Platinum cobalt scale. Using platinum in the form of, very important point, using platinum in the form of, tell me, in the form of how? Platinum in the form of how we are adding? Chloroplatinate ions. Chloroplatinate ions. Using platinum in the form of chloroplatinate ions. That is called Burgess scale. That is called Burgess scale. Units for color measurement. You know it very well. Units for color measurement. Good evening, Joya Fatima. Units for color measurement. TCU, true color units. Units for color measurement will consider as TCU, true color units. Very good. Manu Prakash, Manoj, Ramakrishna. Yes, true color units. Other name is Hazen units. Good evening, Abdul Basit. All are late today. Most of the students coming late. The same true color units, we call it as Hazen units. TCU, true color units, only we call it as Hazen units. Then permissible limit. Permissible or acceptable. Color of water acceptable or permissible up to what limit? 15 TCU. Up to what limit color of water acceptable? Acceptable up to 15 TCU. Very, very important. Very, very important. You need to remember color of water is acceptable up to 15 TCU. 15 ppm. Correct. And the treatment, you know it, na? Treatment. Aeration or activated carbon. Treatment. Aeration or activated carbon. Treatment, we can go ahead. Aeration, activated carbon treatment. The total color information in a single chart we are getting. Total color information. Total what is needed for the color in a single chart we are getting. Got it? Removal of color achieved by aeration and activated carbon treatment. We'll go ahead now. Odor. Again, we don't want odored water. We need odorless water. We need odorless water. odor of water imparted caused by dissolved gases. Odor of water. Water carries dissolved gases. Carbon dioxide, ammonia, hydrogen sulfide. Yes, gases. Very good, Srikandan. Carbon dioxide, ammonia, H2S. Dissolved gases are responsible for odor. Carbon dioxide, ammonia, H2S. And algae, bacteria. Those are also somewhat little responsible. Algae and bacteria also somewhat little responsible. Then odor is measured using. Odor of water is measured using. So we are measuring odor of water using which instrument we are using? Osmoscope. We are measuring odor of water using the instrument osmoscope. Osmoscope will express odor in the units PON, permissible odor number. Osmoscope is going to express the odor in the units of PON, permissible odor number. Osmoscope gives odor in terms of PON. Second one. What is second mode of measurement? Dilution experiment. Dilution experiment will express odor in the units of TON. TON is threshold odor number. TON, threshold odor number. PON, permissible odor number. Very good. PON, permissible odor number. TON, threshold odor number. We'll write down the formula A plus B by A. A plus B by A. Hello Manoj Anaganti, good evening. TON, threshold odor number, expressed by using the formula A plus B by A. Total volume of sample, diluted volume of sample by raw volume. Clear? A is raw water, B is distilled water. A plus B by A. Total diluted volume of water by raw water volume. That is a threshold odor number. Total volume A plus B. Total volume by raw water volume. Raw water volume. That is a threshold odor number TON. Threshold odor number TON. Now, again treatment we can go for the same aeration. Same we can provide treatment. Treatment for odor removal will consider same aeration. What method of aeration we are going ahead? What method of aeration will give for odor removal? Again aeration and activated carbon. What method of aeration we apply for odor removal? Degasification. Degasification, because gases are responsible to impart odor. Gases are responsible to impart odor. Yes, very good Ramakrishna, very good Banu. Degasification, removal of gases from water. Removal of gases from water, that is targeted in the aeration. Degasification. So you understand this odor? Clear? We'll move on now. We'll go ahead. If any limit is asking, acceptable limit you take 0 to 3 ppm. Acceptable limit in ppm, if you want to express 0 to 3 ppm, you'll consider. Not more than that. For odor. Odor acceptable limit you will consider 0 to 3 ppm. Ayush, A is raw water, clearly written Ayush here. A is raw water volume, I have written here now. B is distilled water volume. A is raw water volume, B is distilled water volume. Volumes of raw water and distilled water we are taking. A plus B by A, odor. Threshold odor number TON. A is raw water, B is distilled water. Important questions TSPSC exam. What I am writing, Manoj. This is important for any exam, not only for GATE. The name title is given crash course for GATE. Subject is same, Manoj. Subject will not change. Whatever theory we are studying, the theory only coming in TSPSC. If you have a doubt, after my class, you go and watch your previous TSPSC questions. Same related questions only will be there. Same related questions only will be there. Don't worry. And I will make important points also. I will make important points also for TSPSC. Okay. Taste of water. We require good taste. We need good taste for the water. This is important now, Manoj. Important for TSPSC, given in TSPSC only. Good taste of water caused by. Good taste of water caused by, Manoj. Important and given in TSPSC only. Bicarbonate ions, HCO3 minus ions. Water contain bicarbonates. Water contain bicarbonates. That gives some drinkable taste. Good taste means it is a drinkable taste which feel good for human tongue. That is called good taste. Drinkable taste caused due to bicarbonate ion. HCO3 minus ions. HCO3 minus ions. Again, measurement of taste. Estimation of taste. Taste of water measured by again dilution experiment. Taste of water measured using dilution experiment. What are units? What are units? Flavin threshold number, FTN. Flavin threshold number. Taste of water expressed using Flavin threshold number, FTN, not FPA. What happened, Banu? FPA you are writing. Flavin threshold number, FTN, that is unit for expressing taste of water. The most repeated question regarding turbidity in any state government exam, in IES as well as in GATE. Turbidity caused due to, very important, caused due to, turbidity is caused due to. Turbidity of water is caused due to. Who is responsible to cause turbidity? Very important. Turbidity of water caused due to suspended solids. Very good, Ashwant. Suspended solids and colloids. Suspended solids and colloids. Good. Everyone knows it. Very good. Everyone knows it. Turbidity of water. Turbidity of water is caused due to suspended solids and colloidal impurity. Very, very important. Very, very important. Most important point related to it. Okay. Then turbidity is measured. We'll take one more slide, not like this. We'll go. measurement of turbidity, measurement of turbidity I am writing. So the turbidity is measured based upon light absorption, based on light absorption, based on light transmission or scattering, based on light transmission or scattering. Turbidity is classified into two types. Very good, Srikandam. Measurement of turbidity. Measurement of turbidity is based on two types. Based on light absorption and based on light scattering or transmission. The units here, JTU, based on light absorption. Units are called JTU, Jackson's turbidity units. Jackson's turbidity units. And here the units are called NTU, nephelometric turbidity units. Very important. Turbidity using light transmission or scattering phenomena. NTU, nephelometric turbidity units. JTU, Jackson's turbidity units. Using in English. So always I will teach in English only, Yashwant Kumar, don't worry. JTU, Jackson's turbidity units, NTU, nephelometric turbidity units. And it is measured based on silica scale, the scale of measurement for absorption phenomena. Scale of measurement for absorption phenomena, silica scale. For transmission phenomena, Farmazin scale. For transmission phenomena, Farmazin scale. Clear? Based on light absorption, the scale of measurement is silica scale. Based on light transmission, the scale of measurement is Farmazin scale. The instruments, we are having instruments here, different instruments. We can say Jackson's turbidity meter, Jackson turbidity rod. Will have Jackson's turbidity rod. The name given to measuring scale with respect to chemical. We are using some chemical. Ayush, we are using some chemical for calibration of instrument. Standard chemical used for calibration of instrument. That is silica for light absorption phenomena, Farmazin for light transmission phenomena. The standard chemical used for calibration of instrument, silica and Farmazin. Jackson's turbidity rod, Jackson's turbidometer, Bailey's turbidometer. These comes under light absorption. Then Farmazin scale will carry two instruments. Turbidometer, nephelometer. Turbidometer, nephelometer. Two instruments, only two. This is manual measurement. Instrument is not giving value. And light transmission or scattering phenomena is automated measurement. Instrument, if you put water sample into the instrument, instrument will give the value directly. Instrument will give you the value directly. You are not going to do anything. That is based on light transmission or scattering phenomena. So measurement of turbidity. You got the clarity? Completed writing. Shall we move on? Measurement of turbidity. Have you got the clarity? Completed writing. Shall we move on? We'll go ahead. Very, very important. Very, very important, especially regarding turbidity. Difference between turbidometer, nephelometer. This is the most important point related to turbidity. Difference between turbidometer and nephelometer. Very, very most important point related to turbidity. Difference between turbidometer and nephelometer. In turbidometer, outgoing light, emitted light, whatever light released from water, okay, emitted light means you are passing some light. Consider this is the container, water container. Light is coming like this. So whatever outgoing water, emitted light, that emitted light passes. Emitted light passes. How it is passing? Emitted light passes. Very important. Parallel to the path of incident light. Emitted light passes parallel to the path of incident light. To the path of incident light. In turbidometer. In turbidometer. The most important difference between turbidometer and nephelometer. Yes. Limits are not with respect to instrument, Sai Tejasvi. Limits are with respect to human consumption. Instrument limits are not there. Limits are based on your consumption, okay, how much is accepted for your health, not based on instrument. And in nephelometer, same we can write. Emitted light passes. Emitted light passes. Right angles. Very important. Emitted light passes right angles. Perpendicular to the path. Emitted light passes right angles to the path. Path of whose? Path of incident light. Incoming light and outgoing light are parallel to one another. Turbidometer. Yes. With same intensity. Intensity does not matter here, Ramakrishna. Intensity will vary depending on your impurity. Instrument is not controlling intensity. Instrument will control intensity only in incident light. Only in incident light. So outgoing light intensity depending upon impurity, quality of water. Ramakrishna got the point. Only based on direction we are talking, not depending upon intensity of light, not depending upon other factors. If entering light is entering in this path, exiting in the same path, it is coming like this, going out same like this, parallel to the path. Parallel to the path. It is coming, entering into the container and exit out to the container in the same path. Turbidometer. It is entering into the container in one path, exit out the container in other path. Nephelometer. So it is entering like this, it is entering like this, exit out in this path. Exit out in this path. That is called nephelometer. For any instrument, whatever it may be, nephelometer, turbidometer, Jackson, whatever it may be, acceptable limit, not with respect to instrument, with respect to water quality and human health. up to 5 ppm. Up to 5 ppm. More than this not required. Okay. That limits not necessary here. That limits not necessary. Measurement limits. That limits not necessary, not required. Only acceptable limit for human consumption. Sai Tejasvi. Only we are talking about acceptable limit for human consumption. That acceptable limit for human consumption is up to 5 ppm. That much theory not required here. Means perpendicular to the path means. Yes, Ramakrishna, correct. In your lab, turbidometer only present. If light is passing perpendicular to the path, it is undergoing scattering. It is undergoing scattering, it will give more accurate value. Because you have two analyzers in nephlometer. The two analyzers will analyze the sample very well. You will get more accurate value in nephlometer. Clear? Clear, we'll move on now. Perpendicular to the path, light transmitting, entering like this, exit like this. So, scattering is going to take place. Deflection of light is going to take place. It gives more accurate value. We'll move on now. This ends physical quality analysis. What is required regarding physical quality analysis? That is completed. Exactly needed. Not more than, not less than, exactly needed for GATE EE physical quality analysis, that is completed. Clear? We'll move on now. Now, chemical quality of water. Chemical quality of water. We are having now chemical quality of water. First, we need to know here unit conversions. A precise notes I will give. We have a lengthy process regarding chemical quality of water. We have a lengthy process here. Yes, Ayush, for GATE, as of now, the theory that much is enough. Only the thing you need to practice more problems in chemical quality. Theory, as of now, that is enough because you don't have that much time. You have only 2 months for the GATE. So, going through so much theory, so much concepts, it is now unnecessary. Just bits and byte like model, you go for theory. Focus more on numerical questions. Clear? You are not in the beginning now. You are in the ending phase of GATE exam. So exactly what is needed, you learn it as of now. Later on, if you want to go for 2022, then you can go for full length course. Now this crash course is enough. Now unit conversion. Any chemical given in mole per liter. Any chemical given in mole per liter. You have to convert to mg per liter, milligram per liter. Simple formula I am writing. Simple formula I am writing. Direct shortcut. I don't want to drag it here. X in milligram per liter is equal to X in mole per liter into X in milligram per liter is equal to X in mole per liter into molecular weight of X, molecular weight of X into 1000. Completed. Finish. For example, carbon dioxide is given. Carbon dioxide in mole per liter provided. Multiply carbon dioxide molecular weight and 1000. with mole per liter, you will get milligram per liter. So don't think so much theory, so much chemistry here, just blindly follow the formula. So because this is not the time I am saying, this is not the time, only 60 days there for GATE exam. Just you blindly by heart the formula, go ahead. Chemistry that much not required to you. X in milligram per liter is equal to X in mole per liter into molecular weight of X into 1000. Second model, when equivalence per liter is given, you want to convert to mg per liter. Same. Equivalence per liter is given, you want to convert to mg per liter. Same you take X in mg per liter is equal to X in equivalent per liter. Instead of molecular weight, you take equivalent weight. Equivalent weight of the given chemical. Equivalent weight of given chemical into 1000. So these are shortcut formula. I am revealing the shortcut formula. I don't want to give my student to give so much chemistry and they will confuse in the exam. I don't want them to confuse in the final exam. So straight away formulas I am giving. Just multiply with equivalent weight and 1000. Your equivalent per liter converted to milligram per liter. Equivalent per liter converted to milligram per liter. Last one. Milligram per liter converted to milligram per liter as calcium carbonate. Mg per liter converted to mg per liter as CaCO3. So X required in equivalent to calcium carbonate. Mg per liter as CaCO3 is called X equivalent to calcium carbonate. Clear? That is equal to X is given mg per liter into 50. I am not writing entire formulas and derivation, directly writing 50 into equivalent weight of X. X in milligram per liter into 50 by equivalent weight of X. Direct. Nothing to worry here. You understand? Mg per liter to mg per liter as CaCO3. X in mg per liter into 50 by equivalent weight of X. No need to worry about calculations, all the things. Only you know how to estimate equivalent weight, that is over. Only if you know how to estimate equivalent weight, your question is completed. So I am giving formula for equivalent weight also. Equivalent weight of any chemical is equal to molecular weight by valency. Simple. Equivalent weight of any chemical is equal to molecular weight by valency. Examples, Ashwant, tomorrow we will solve in Unacademy app. This is concept question, Ashwant Kumar. Numericals, tomorrow I will solve. Today I will finish all theory, formula, theory and everything. Tomorrow in Unacademy app we will solve numericals related to it. So today you learn the concept, theory here. Come to Unacademy class and will solve numericals. Got it? Is it clear for everyone? So okay, as Yashwant has asked, I don't want to disappoint Yashwant. I am taking calcium chloride. Calcium chloride is given 0.025 mole per liter. Calcium chloride is given 0.025 mole per liter. 0.025 mole per liter. Now I am converting to mg per liter as well as mg per liter as CaCO3. So for that I need molecular weight. Molecular weight of calcium chloride. Calcium is 40, molecular weight will take CaCl2 molecular weight. calcium is 40 plus 2 into chlorine. Chlorine is 35.5 I am taking. 71. Cl2 is 71. Total CaCl2. What is the total CaCl2? Calcium chloride 40 plus 2 into 35.5. 111 is molecular weight of CaCl2. 111 is molecular weight of CaCl2. Is not it? 71 plus 40. Now CaCl2 in mg per liter I am writing. CaCl2 in mg per liter I am writing. Very good, Deepa. Nice. Mole per liter 0.025. Molecular weight 111 into 1000. So what is CaCl2 in mg per liter? 2775. Deepa given. 2775 mg per liter. Milligram per liter. Yashwant Kumar, you understand it now? Yashwant Kumar, you understand it now? CaCl2 in milligram per liter 0.025 into 111 molecular weight into 1000. 2775 mg per liter. Now the same CaCl2 I want in mg per liter as CaCO3. Mg per liter as CaCO3 I required. How can I take 2775 into 50 divided by 50 divided by equivalent weight required na? Equivalent weight of CaCl2 molecular weight 111 by 2 valency 2 55.5. Equivalent weight of CaCl2 molecular weight by valency 111 by valency 2 55.5. Here we are taking 55.5. No, not 111 Ramakrishna. 111 is molecular weight Ramakrishna. This is molecular weight M. We need E. What we have written here? Equivalent weight na, not molecular weight na, Ramakrishna. So we are expressing with respect to calcium carbonate. This is the answer. 2500. 2500 mg per liter as CaCO3. 2500 mg per liter as CaCO3. So that much chemistry not required to Yashwant Kumar. That will be learned in full length course. In the crash course, that much chemistry, if you start explaining each and every point, it will take 100 hours. You just learn. In exam they are asking as CaCO3, we are solving. Okay. In exam they are asking in mg per liter as CaCO3, we are solving. So that much you come to full length course, you learn what is, how, why it is required as CaCO3. Why it is required as CaCO3 and all those things. That much chemistry I told in the beginning itself. We don't want chemistry. We are civil engineers. We are going to solve a civil engineering GATE exam. You just learn it like that. Okay. If anything required, you come to full length course. How much time you want, each and every doubt I will solve there. No problem. But here exactly what is needed for your GATE point of view, exam point of view. Clear? Completed this one? Then, everyone, is it clear how the values are coming? Then, the first parameter will consider dissolved oxygen, DO. First parameter we require dissolved oxygen. Dissolved oxygen, DO. So here different points you are having. You directly write down different points. Minimum DO required for aquatic life in a river. Aquatic organism, water living animals are there. Fishes, prawns and other animals, water living animals are there in a river, canal. So that DO required to continue life of any aquatic organism. Sai Tejasvi, is it equal to 4 or greater than 4? Is it equal to 4 or greater than 4? Greater than. For any aquatic life we are talking Sai Tejasvi. Greater than 4 ppm. Not exactly for Ramakrishna Srikandan. If they are asking about aquatic means fishes, prawns, whatever water living, 100% of water living animals to continue. The question is about for fishes. In so many classes of mine, I clearly mentioned about it. Question is given for fishes. Take it exactly equal to 4 ppm. Exactly equal to 4 ppm. Yes, correct Sai Tejasvi. For other organisms, all organisms to continue, including fishes, all will continue greater than 4. For exactly for fishes, 4 ppm. 4 ppm. Means if water DO is 4, only fishes will continue. Other organisms disappear. DO less than 4. What happened? DO less than 4 ppm. DO less than 4 ppm. No aquatic life. Water is considered as sewage. DO less than 4 ppm. No aquatic life. Water is considered as sewage. Optimum DO for human. Optimum DO for human. Tell me optimum DO. Optimum DO for humans 6 to 7 ppm. Saturated DO. Saturated DO CS. The best quality of water, representing best quality of water CS 9.2 ppm. Optimum DO 6 to 7. Optimum DO 6 to 7. Saturated DO 9.2 ppm. So we have so much chemistry regarding DO experiment. We don't want all the things. Just name of the method. Method of DO estimation. Just you remember name of the method. Method of DO estimation. Method of DO estimation. Winkler's method. Saturated concentration. Ayush. Saturated. Yes, saturated. C, concentration. Saturated oxygen concentration. CS. Winkler's method. Method of DO estimation is Winkler method. You remember here, indicator is starch. Indicator is starch. Titrant is sodium thiosulfate. Indicator is starch. Titrant is Na2S2O4. Indicator starch. Indicator is starch. Titrant is sodium thiosulfate. Na2S2O4. Other than this, only one point you require. Excess DO in water causes. Never they will ask less DO. Excess DO in water causes. What is excess DO causes? Tell me. High concentration of DO. Excess DO in water causes corrosion. Corrosion of metal. Corrosion. Excess DO is going to cause corrosion. Yes, corrosion of metal. Correct. Excess DO is going to cause corrosion of metal. So we have studied around 3-4 pages in DO. This is enough for a crash course, GATE. Very important limits. Indicator titrant, excess DO causes corrosion of metal. Other than this, nothing is needed. Okay? We'll continue tomorrow. Human beings very happy, health increases. Ramakrishna, your health improvises, your self-life increases, age increases. You feel very happy. If DO is more, you feel very happy. Your system, your blood circulation system, your body, metabolic activity go on good. We'll continue the same session tomorrow 4 p.m. Chemical quality and biological quality. Tomorrow we'll complete quality of water in the same session at YouTube. And 8 p.m. we are going ahead with problems session in Unacademy. All quality analysis problem, water demand problems will go ahead at 8 p.m. Very important thing, excess means more DO. DO greater than 9.2 Ramakrishna. More DO in water. You feel very happy. Clear? 4 p.m. YouTube session and 8 p.m. Unacademy problems we are going to discuss. Those who are watching in YouTube, if you want to continue the numerical sessions in Unacademy, you download Unacademy app, install the app, and while installing, if you want to watch any free class, it will ask a code. It will ask a code. That code for your installing app in Unacademy, that code is KP Civil. Use the code. Use the code KP Civil. Then you watch all free classes of mine. Clear? While you are installing, new students I am saying, no, today no class at 8. In YouTube I saw a video and after paying money no one will respond. What response you want? Yashwant Kumar. Yashwant Kumar, this is my number. Whatever the response you want, I am with you. I will support you. You just WhatsApp me. Okay? Whatever support needed your preparation, whatever struggle, whatever doubts related to Unacademy, you just WhatsApp me, Yashwant Kumar. I will be responsible. I will talk with you. Okay? Don't worry about it. Don't worry. Whatever doubts, queries, whatever you want, you talk with me. Today no class, Anudeep. Today 8 p.m. there is no class. From tomorrow we'll continue again. For 2 sessions. 4 p.m. YouTube, 8 p.m. Unacademy. From tomorrow onwards we'll continue. Okay? And if you want to download Unacademy app or your friends, your brothers, your juniors, one and only KP Civil. Remember, one and only KP Civil. The best guide, mentor for you, best teacher for you, who will take care what is required for your exam preparation, only KP Civil. Remember that. Okay. Bye-bye all of you. We'll meet again. Tomorrow at 4 p.m. we'll meet again. Thank you one and all. Bye-bye all of you.